these. All right, there we go. So this question apparently is we could use a simulation. We could simulate all the combinations here. So for instance, this is one, and we pick the small or the shorter one, right? And then we have this amount of water. And then we also simulate this part, and we also do this, and then do this, and keep doing it, right? Okay, all the way here. This is the first iteration. Second iteration, we start with this line here, and we check which one is taller, which one is shorter. This one shorter, so we take this amount of water, and we also update the maximum water containing here. And then we keep going, all right? So then we check this one and that, and we pick this, and apparently this range, all right? I guess this is 1 and 1, and but for the height is going to be different, right? Okay. And then we check this one here, and now I guess this one contains more water, right? So we pick this one. So apparently, if we simulate the problem, apparently we can solve the problem, right? Okay. So, and then what we really need to do is, first of all, okay, we need let me have this one here. Okay. All right. Today is November 2nd here. So that the questions. All right. We need to update the maximum or the curve max area, right? Curve max area. And the second of all is going to be a simulation. Okay, simulation. Simulation for that, because we're checking two lines, right? So it's going to be a double loop here. And in order to check this one, okay, we also need to create a formulas. That is going to be area equals that one is going to be, I guess, is a height of I, and I guess this one is going to be height of I and the heights of J, and we're going to pick whatever which one is smaller, right? So therefore, we need a method such as that, and then we multiply by the the base, right? Which is, I guess, is J minus I, right? So therefore, we can have the base, okay, the distance. And I guess this one should be okay for the area, right? So we have the height, we have the length, we have the width, so we can calculate the areas here. And we also check the current max. So therefore, there should be a find the max method here, right? So that's going to be very easy. So overall, it's going to be this. Okay. And then let's dive into the code here. So first off, I guess let n equals height, the length of height, right? And the next one is going to we need a double loop as we agree, right? Okay. And then for j in range of something here. Okay. For this range, it's going to be the full range, and this is also the full range, right? Okay. And then what we need to do here is going to be, we need to create a area, right? So the area is going to be the minimum between something. So height of and the height of something. So this is J and this is I here, right? Okay. And whenever we have these, we can find, let me just have this is height, all right? This is minimum height, okay? And then we have another one is going to be base. Base or maybe W, okay. Width is going to be J minus I. And be aware, so the range of J is supposed to be starting from where I plus 1, right? Okay. Because we're checking the one next to it. Because the simulation, right? So this is I, so J starts here, right? J starts here. If I starts here, J starts here. If I starts here, J starts here. J cannot start before I, right? Okay. So therefore, we just update the starting range of J by I plus 1 here. And then we subtract that. Okay, so we have the current width, right? Good. And then we can create area. So we just say A equals H times W. And we also want to update. Okay, so the update, all right, so we can simply just call that the result is 0 here. And the result, I guess where do we do? I guess is when I guess we can update the area right now, right? So that is res equals max between res and the A, right? So then we, I guess we can update the result in real time here. And the overall, I guess, pretty much is going to be that. And let's run this code. I guess for these, we'll pass probably yes the sample case here because simulation. This is a very obvious simulation problem here. Whenever the question is asking you to find the maximum or minimum amount of operations or whatever the blah 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 in a certain range, something in the most of the time you can simulate. You can simply simulate every possible combinations. But the downside is if you submit, usually the time complex is going to be huge. It is because, I mean, yes, it is a simulation. It's just too slow. Um, you will be seeing that, I guess. So, but these will pass probably, yeah, almost 90%. Okay, I guess 53 out of 63 something. Um, this is the most naive way to solve the problem, but there are several other ways to optimize the solutions. And that is going to be the two pointers. So the two pointers is, okay, um, you have one pointers here, right? Or you can simply call them L, and this is R, right? So you can simply just check these two's current range rate. So and then apparently this one is that the current maximum water containing is these. This is pretty small because okay, even though you have the full range here, right? Okay, so this is n times one, I guess. Okay, and this is basically well, if n is super huge, well, it's huge, but we didn't check these yet, right? So these, I guess, could be better, right? Okay. So that simply means whenever you have a shorter one, so you want to push the shorter one to to the forward or to the backward directions, right? So in terms of these, you push L forward, okay. Add it right here. Then you check this one. Apparently, this is a much better result, right? Because I mean, by seeing it, right? Okay. Now, of course, you also do a calculations. The calculation, the range is basically still R minus L, right? Okay. Because R and L are changing all the time. So this is a dynamic rate, okay? And what is going to be the height? The height is whatever is still the mean between, well, L and R points pointing to the vertical bar, right? Okay. And then now this one is shorter, so we push this one here, right? Okay. Because and we also need to calculate the current area as well. Okay. We push that here, so we have this one here, and this one stays. All right. You do not move the one is taller. But now, as you can see, so now the performance is bad, right? Okay, so it's less effective. So and then, all right, so since this is small, right, we also push this to the leftward. Now it goes up, right? Now we have this one here. Then we have this range. And then since they are equal, right? Okay, so if they're equal, we can simply move whatever one of those here. And if we move this one here, okay. And then we have this one here, right? Okay. And then this one shorter, we keep moving here. And then we keep moving here. And then we keep moving here. And eventually we have this very small one. So it seems like the best of the solution, I guess, is probably this one. As you can see, by using two-pointer method, we could definitely solve this problem by using ON, right? Okay, just one single pass, and then solve the problem perfectly, right? Okay. And for that, I'm going to give you probably 10 or 20 minutes to think, okay, how would I implement a two pointers method to solve this problem? All right. Okay.
Okay.
All right, in part two, so I'm going to show you the optimal solutions. Overall, okay, your solution looks is on the right track though. Yes, you do need a single loop here and a formula and increase these one and that. But for these, okay, well, yeah, okay, well, okay, let me show you the way to solve this problem. So basically I need to, yes, I is 0, j is length -1, that is good. Okay, and area is 0. Okay, everything is good. So this is a very good starter kit here. First off, I'm going to use a while loop here. So while I is less than or equals to j, right? Okay. And then what do I need to do? So first of all, right, I need to create, like I can simply use area. Okay, area equals, or simply I'm going to use a cur a equals, that is going to, I'm going to pick um, the minimum between height of two vertical bar rays, and I'll be modifying by the width, which is j minus I here. Pretty straightforward. And then I'll just fill out the blank here, I and j. Good. And then I'll be updating area equals maximum between which one's bigger, so cur A and area. Because it's guaranteed that area must be bigger than 0, right? Okay. And then I need to do the two pointers trick here. So I'm going to have a if statement here, right? If what? So height of something is less than height of something, right? And I'll just put it I and a j here. So that simply means, okay, what it doesn't really matter, okay, which one, it doesn't really matter which one is which, right? So because I just need to find the one is a shorter. So if the I is a shorter, so I'm going to push, I'm going to push I forward, right? So because I is a left pointer here, so +1, and vice versa. So vice, that simply means, okay, so J is too big. I'm going to move that leftward, so J minus by 1, right? Okay. And then simply by doing that, we are able to, I guess, pretty much that's pretty much what I want to do here. Okay, so let me submit. So there I have two sample cases passed. Pretty neat. And I'm going to try if these will pass all the cases here. And the answer is yes. Okay. Sometimes, all right, you probably want to ask, am I do this later? Yes, you can also do this later after the iterations here because no matter what, this wouldn't affect these formulas here, right? This wouldn't affect the formulas here. And but what if you do these? Okay, but if you do these, it is a kind of a questionable. Why is it questionable? Because j minus I is modified already, right? So if you do this later, it could possibly, I mean, no, not possible. It would definitely affect the overall solutions here, right? Okay. So therefore, for this part, it has to be before the iterations here or the selections here. And as you can see, so this is a very decent algorithm principles, right? These are principles of algorithm. So there are three principles, right? So three, which is sequencing, right, and iteration and a selection. Sequencing, all right, if you mess up with the order, I mean, apparently it doesn't work. Iteration, all right, if you set up the for loop or while loop wrong, it wouldn't work. Selection, all right, so if you set up the selection wrongly, I mean, it gives you the wrong answer, right? Okay, so this is exactly the principles of algorithms here. And for these, all right, and then submit this question again. It is going to be a full score. I mean, yeah. And for these, somebody would say, okay, do I use equal or not equal? For this part, actually, it doesn't really matter. If you remove the equal sign, it's still acceptable. Okay. Um, there we go. Okay. There we go. So this is going to be the official solutions here. So I'm going to probably visualize the solutions again. All right. So why it works. Okay. So we put a left pointers here and the R pointers here, right? Okay. So this one's supposed to be moving to the left and this one's supposed to be moving to the right, right? Okay. At the very beginning stage, all right, so they have their initial positions here, right? Okay. Uh, and you can also use a POS-L and a POS-R. I mean, sometimes it makes more sense. If you really master this, you can use I and the J because, I mean, you really know where you want to move your pointers, right? Okay, but at the beginning age, you can definitely use more meaningful syntax, right? Okay, so post L, post position, position L and the position R. And at these very beginning positions here, right? So the area is going to be these, and this is exactly these process, right? And then, all right, so you have the if statement here. You are checking which one is smaller. So apparently L is smaller, so you're going to move these one to this position. You do not move R at all, right? R stay the same. As you can see, so this is basically something like a binary, right? So, or it's like a Boolean, okay? So it's either true or false, okay? You only do one operation at a time, and then you pass the area right away. And then now L is here, right? Okay. So, and then you are going to pick this range here. And then next round, since this one is less than that, so you're going to move R here, right? And then, well, so this one is smaller, right? Smaller than that. And so you point R here. So now they're the same, all right? So right here. So because we check why it works is because this one this one will fail, right? This one wouldn't work when they are equal. So it will do this. So that's why it doesn't really matter if they're the same because you have these conditions here. This one fails, it will just move the J or the J. J is always leftward, right? Okay, so the reason why it works all the time is because you have one checker here, right? Okay, even though they're the same level, it's still working because the next the opposite logic would be triggered, right? Okay, so this one would be moved here, and then smaller, right? And then smaller, and smaller, and smaller, and then eventually R and L they meet together, right? Okay, so and then the algorithm stop. And well, as you can see, it's just a single loop to solve the problem, right? Overall, just like that. All right, okay. Does this make sense to you? Oh, Alex.
Oh, hello. Yeah.
Good. Okay. So now I want you to use this technique to solve the problem. Okay. And there are also some other similar questions, such as maximum tastiness of a candy basket and a house rubber floor. Next question I want you to do probably maximum tastiness of a candy basket. This is going to be a very similar question, a very similar question. And you should also have some similar question as well. It's like a candy can feast, right? Okay. So therefore, as you can see, so medium level question is probably bronze level first or two questions. Okay. So therefore, besides user code question, you do have tons of lead code question you can practice. All right, good. Okay, I'm going to forward this question to you as well. And of course, finish your algorithm here. So now, please implement the new code below. All right. You also want to keep your original code here because therefore you can always check your old code, right, and compare with the optimal code. By comparison, you can improve yourself, right? Good. Okay, so now let's maybe have a 10 minutes break, and then after that, let's get back to lesson, all right?